Hello, hello, hello! Welcome back to the Blackboard. Oh, it's been a while. We are going to continue on with the lecture of linear systems, differential equations, more specifically the first order. And so this example is going to be all about converting the following higher order differential equations to equivalent systems of first order differential equations. So when we discuss the lecture, we just kind of have to substitute, like bring in dependent variables and then substitute them in, and we'll have a first order differential system. So let's get started. So for the first one, we have a second order system, and it'll be x double prime plus 3x prime plus 7x, and that is equal to t squared. So what we have to do is we are going to create a function. Well, the way to do it is we are going to move everything to the right side except for x double prime. So this will be equal to x double prime is equal to negative 3x prime minus 7x plus t squared. And so what we're going to do now is we are going to let x double prime equal to some function f of t, x, and x prime, because we have t, x, and x prime. And so now we're going to bring our dependent variables. So our x1 and x2. And so the reason why I put them under there is because we're going to let x1 equal to x, and then x prime going to be equal to x1 prime, which is going to be equal to x2. And so now what we're going to do is we're going to substitute this in and create our first order system. So because it's a first order system, that means we're going to have first orders on the left side. So it's going to be the x1 prime. What is that equal to? Well, we mentioned that x1 prime is equal to x2. So x1 prime is going to be equal to x2. And so x2 prime will be x1 double prime, which is equaling to the function that we defined. So we just have to substitute this in, and so this will be equaling to negative 3x prime, but we know that x prime is going to be equaling x2, so this will be negative 3x2 minus 7x. So 7x, x is equal to x1, so we can replace x with x1, and then t squared, which is remain the same. And so that would be the solution for the first one. Part B, again, we're going to do the same thing. The highest order derivative stays on the left side, and everything else goes to the right. So this would be x, the fourth derivative of x is equaling to negative 6x double prime plus 3x prime minus x plus cosine of 3t. So again, we're going to let this be equaling to some function of t, x, x prime, x double prime, x triple prime. And we are going to substitute in our x1. So our x is going to be equaling to x1. Our x1 prime, actually let me just rewrite it like this. We're going to have x equaling to x1. We're going to have x1 prime equaling to x2. x2 prime going to be equaling to x3. And then x3 prime equaling to x4. And so our system will be x1 prime is going to be equaling to x2. x2 prime is going to be equaling to x3. x3 prime is going to be x to the fourth. And then x4 prime, well, what is x4 prime? Because x4 prime is the second derivative of x3 prime, then that means as the third derivative of x2 prime, which is the fourth derivative of x1 prime, which is the equation that we defined in the first place. So it's just, again, substituting it in. So this would be equaling to negative 6. So because it's x double prime, it will be x3. So it'll be negative 6 times x3, and then the 3x prime will be the 2x, so this will be plus, not 2x, x2, it'll be plus 3x2, then minus x, which will be x1, and then plus cosine of 3t. So that will be our system for this ODE. And then you can verify by just kind of plugging it in, because if we do x1 is equal to x, so x1 prime will be x2, which is x double prime, and then x2 prime will be x triple prime, and then x3 will be x to the fourth. I'll take that back. x1 prime will be x1, this would be double prime, and then this would be triple prime. There we go. So now onwards to the last two parts. So the last two, these look a little bit interesting, and they're not like the ones we've done before. So this one is t squared x double prime plus tx prime plus t squared minus 1, and all multiplied by x, and is equal to 0. But even though this kind of looks weird, the same method applies. We're going to move everything that's not the highest order to the right side. So this would be t squared x double prime is equal to negative t of x prime minus t squared minus 1 times x. Or another way to write this, if we distribute the negative, this would be 1 minus t squared times x minus tx prime. And again, this is going to be equaling to some function f t x, because it's second order, it would just be x prime. And so now we are going to let the substitution come into play. So again, we're going to let x equaling to x1. x1 prime is going to be equaling x2, and that's pretty much it. So our system will be x1 prime is going to be equal to x2, and x2 prime will be, well, it won't be the function, because the function is only equaling when it's x2 prime times t squared. So this will be t squared times x2 prime, and then that will be equaling the function. So it'll be 1 minus t squared times x1 minus tx2. And so this would be our system and our answer. So if you've noticed, the last equation will always be the same number as the nth order. So because here we had a second order, our last equation would be x2 prime. In the other previous example, we had a fourth order. This would be the last one would be x to the 4 prime, and then the same one second will be second. So our last example is, this looks kind of interesting because we have a system already, but this is a system of second order. So what do we do here? Well, same thing applies. The only thing is you're just doing it twice. As always, I'm gonna move the highest order, or keep the highest order on the left side, move everything to the right. So this would be x double prime is equal to negative 3x prime minus 4x plus 2y. And then for the y part, it would be y double prime equaling to negative 2y prime plus 3x, not plus, I can't erase, minus y plus cosine of t. And so now we're gonna have two equations. So we're gonna let x double prime be equaling to f of t, x, x prime, y, and y prime. Y double prime, we're gonna let that equal to g, t of x, x prime, y, and y prime. And so now we can bring in the variables of x and y. And so what we're going to do is we're going to let x1 equal to x, making x1 prime equaling to x2. And then for y, same thing. y1 is going to be equal to y, and y1 prime is going to be equaling to y2. And now that we have that, all we have to do is substitute that in to our equation and create a system. So the system will be 4 because we have 2 of second order, so it'll be 2 plus 2 is 4. And so our system will be x1 prime is going to be equal to x2, and then x2 prime is going to be equaling this portion right here. So this would be negative 3x2 minus 4x1 plus, that is a terrible one, 2y1. And then we'll have our y prime equaling to our y1 prime equaling to y2, and then y2 prime equaling to the second equation here that we created. So this would be negative 2y2 plus 3x1 minus y1 plus, gotta move a little bit to the right, plus cosine of t. And that will be our solution to the ODE, or not ODE, to converting this into a system. And that'll be pretty much it. So hopefully this helped you guys get a better understanding on converting these into first order systems. And I'll see you guys in the next example.